This is the Algebra 2 with Trig, Unit 2A review. We're working on graphing polynomials. First of all, we learn about polynomials that yes, this is a polynomial. It's not in standard form. We would write it as -8 x to the fourth. Then your next largest exponent would be plus 2x cubed, and your next largest exponent would be positive 5x squared. Then your final, there is no x, but there is a negative root 2. It's okay to have a square root in the polynomial, it just cannot be on the variable. The degree for this would be 4. We often like to talk about how that is even. That tells us a lot about the equation. The type, because it is 4, it is quartic. The leading coefficient is the number in front of the largest exponent, so it's -8. We often like to talk about how that is negative because it helps tell us about the equation. Because it's even, we know it would go in the same direction for the beginning and the ending of the graph, the end behavior, and the negative tells you it'll open downwards. On this one, this is not going to be a polynomial because of the -1. The -1 is going to make this -8 over x to the first power. That's what that would really be, and you can't have x in the denominator for a polynomial. So it doesn't have a standard form. Really, it doesn't have a degree. It would be your largest. I guess it has a degree. The degree of this equation is 5, and in this situation we would call it fifth. And the leading coefficient would be a -2. Here we have synthetic substitution. It is very important that you learn synthetic substitution for the future. We're going to look at the leading coefficient for each term. So we're going to use the 7, that's x to the fourth, then x to the third is -3, and x squared is 1, and x is 5, and x to the no power is -9. So every term is represented. So we drop the 7 and multiply, add them together. So we multiply here with the 7, we multiply here with the 11, we multiply here with the 2, and we multiply here with the 51. And when you add the 51 with the -9, you get 93. So f of 2 equals 93. Here we're looking for the largest exponent because we're going to need to rewrite this in standard form in the correct order. There are 0 x cubes, there are 0 x squareds, there is a 7x, and there is a +1. So when we're working through these, we want to be sure to hold the place values. So -1, 0, 0, 7, 1. Now we can drop that down and multiply, add it together 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 to get -29. So f of -2 equals -29. Here we're looking at this equation, which might help if you would recognize that if you don't have parentheses around an x, that is just x plus 0. X plus nothing. It's just x, which is fine. But x plus 0, x minus 2, x plus 3. Now this x plus 3 is squared, so that means we have to write it 2 times. So we really have a fourth degree. All right, in this case, we're really just talking about it being even. But if you like to talk about the 4, you're welcome to do so. But it's the even that we're looking for when we're graphing. The leading coefficient is positive. Okay, it's a positive 1, but the 1 is pretty irrelevant for us. We're mainly talking about the positive aspect. So because it's positive, we know the graph is going to continue in the upwards direction. Because it's even, we know that it will go in the upwards direction to the left also. Our zeros, we're going to have one at 0, we're going to have one at positive 2, one at negative 3, and another one at negative 3. So that's called a double zero. So our graph is going to come down, bounce, and then go through the other 2 zeros. At this point, it doesn't matter how far down or how far up you would travel with your graph. So our end behavior, as we look to the left, as x is really small, we notice that the graph is above it. So that means it goes to positive. When x is large, we know that the graph is above it. So it also goes positive. And that's going to be because they're going the same direction, we knew that because it was even. Even will always go in the same direction. In this case, both up. All right, so our next one, we have x equals negative 4 as a 0, x equals 2 as a 0, and x equals negative 1 as a 0. There are 3 distinct numbers, so this is odd. It's an odd degree. It's 3 if you really want to highlight what the degree is, but the main thing we're interested in is it even or is it odd? Because that tells us it opens in opposite directions. The leading coefficient is negative. Yes, it's a negative 2, but the negative is what really tells us what's going on. Because it's a negative, we know it's going to be dropping to the right. That's what a negative does. It falls to the right. A positive increases to the right. Because it's odd, we know that the graph is going to go in the opposite direction. So then we plot our zeros. And we have no double zeros. We have no bouncing. So it just goes through and through the graph. Okay, we would like you to write your equation. X minus 2, x plus 3 squared. This is g of x equals negative 2. X plus 4 is kind of a long one. X minus 2 and x plus 1. The end behavior, when x is negative, the function, when x is to the left a long way, not just a little way, but a long way, the graph is above it. So it's positive. When x is positive, not just a little positive, but like infinity positive, the graph is below it. So because it's an odd degree, we know the graphs open in opposite directions. All right. This one, we have negative x plus 1 and x plus 1 because it's squared. We're going to have the binomial written twice, and another x plus 3. So this is a third degree. So we would call this odd. If you want to talk about how it's 3, that's fine, but we're really looking for the odd. All right, now some different terms. Number of distinct zeros. Here we have 3 distinct zeros. Here we happen to have 3 distinct zeros. Here we're going to have 2 different distinct zeros. We're going to have x is -1 when we do the zero product property, and x equals -3. So we have 2 distinct different zeros. One of those is a double zero. One of those is going to bounce. So we know, because it's negative, the leading coefficient is negative, we know that the graph is going to be opening downwards. Because it's odd, we know it's going to be going upwards. It's going to go in the opposite direction. Now we're going to have a 0 at negative, and we're going to have -1 and -3. So really, I can move my arrow that it's going down a little bit more over. It doesn't go down, doesn't get over very quickly. So remember, we're supposed to be having a double zero where x plus 1. So that's x is -1. So it's going to bounce at x is -1, and then it's going to proceed through. So this is g of x equals negative x plus 1 squared x plus 3. Don't worry about how high and low the graph is going for the local minimum. We're just trying to understand what are the end behaviors. Can you read that from the equation? The turning points. Here, when it's a third degree, there can be n minus 1 turning points. So there can be a 3 minus 1, which is 2 turning points, is the maximum. Sometimes it'll actually trick you and only have 1. It might have it different than that. But here we clearly see that it has a turning point at that 0 and it has a turning point down here for a minimum. So it has 2 turning points. For factoring, we know x and x is going to make x squared. We need to come up with 2 numbers that multiply to be 63, that add to be 16. So 63 is 9 times 7 is 63. If they were both negative, it would multiply to be a positive, and it would add to be a negative. So if the leading coefficient is a 1, you can use a guess and check format. It's pretty easy to do when the numbers are somewhat simpler. But when the leading number is not a 1, it makes it a little trickier. Guess and check is still reasonable, alright, but I would like, since we're making a video of this, to show you that 2 times -6 gives you -12. That adds to be 1. You're looking for 2 numbers that are going to have different signs to multiply to be -12, and the larger number has to be positive because you're adding to be a positive. So -3 and 4. So we're going to use factor by grouping to help us organize out what the factors are for this. We break this into 2 groups. We factor out what we can, and that's just the GCF of x. And we're left with a 2x minus 3. Bring down your sign. You'll always have that exact sign, so that's why I like to make my groups and not include that operation. Factor out what you can. I know 2 goes into both of those. When it does, I would have a 2x left over and a minus 3. Notice that the parentheses are exactly the same. So I would have x plus 2 and 2x minus 3. You could write it in opposite order. That would be fine. This is the difference of 2 squares. This is 3x that's being squared, and this is 5 that's being squared. If you take the square root, you can see that it's 3x. If you take the square root, you can see that it's 5. So to produce that, we're going to write conjugates which produce nothing in the middle. Here, if we were to test it, 3x and 3x makes 9x. Positive 15 and negative 15 make nothing in the middle, and 5 and 5 make 25. So you can check your work for any of these factoring questions. Next, we're going to write our own polynomials. This polynomial we're supposed to write is going to have the third degree. It's going to have two distinct zeros, and it's going to have a negative leading coefficient. Now, every person could write a different equation. They're all going to be different. So really, no one should actually have the exact same one. Chances that you land on the same numbers. Two distinct real zeros. So I'm going to pick a real zero here, and I'll pick a real zero here. We'll call that negative 2, and we'll call that 1. I need to make it a third degree with a negative leading coefficient. That means it's going to be going downwards and going upwards. Now it's going to be up to me how I want to make this ride. If I want to make it bounce at the negative 2, or if I wanted to make it bounce at the positive 1. But in this case, to get negative 2, I have to have x plus 2. To make it bounce, it has to be squared. To get it to go through 1, it needs to be x minus 1. To make it go down to the right, I need to have a negative number in front. We often like to write either y equals or f of x is a real common one for function notation. This equation meets the requirements of a negative leading coefficient, two distinct zeros at negative 2 and 1, and it's a cubic equation. It has a power of 3. If you were to multiply this all out, it would be x cubed with a 2x and an x and a constant. Here we're going to create a polynomial with the same end behavior as a quadratic function with a positive leading coefficient. So a quadratic goes up in both directions, right? That's what a parabola looks like. We want to have 4 x-intercepts. So I'm going to call this one like negative 3, we'll call this negative 1, we'll call this 0, we'll call this 2. So we've got to draw this so it goes through each and every one of those. Okay? So to do that, we're going to have x plus 3. That's how we get to negative 3. X plus 1. Now this is just x plus 0. So we can just put the x in front. And x minus 2. There is no bouncing. We didn't have to bounce anywhere to get it to go in the right direction. So this is f of x equals. Now we're going to create a polynomial. We want this to go through negative 7, positive 9, and 0. We want it to have the same end behavior as x squared. So x squared opens up like a parabola. But it's got to come down. It's going to have to do some bounce so it can go up again. Otherwise it would go down, up, down. So it's got to bounce somewhere. You can make it bounce in the middle. You can make it bounce on the end. You want to make it bounce in the middle, it would look something like that. If that was your situation, this is negative 7, This is 9. This is, of course, 0. So if it's 0, we're going to have x plus 0, or just x. It's bouncing there, so it's going to be squared. X plus 7 to get it to go through at negative 7. And x minus 9 to get it to go through negative 9. It'll have a leading coefficient to make it go up. So let's use g this time. G of x. We're going to describe the end behavior of this equation. We notice that it's in order, so it's got an odd degree. So that means it goes in opposite directions. And it has a positive leading coefficient. So it's going to do something, has a positive leading coefficient, so it's going to be going in that direction. And it's odd, so it's going in opposite directions. That's really all we need to know. For end behavior, we don't care how many times it curves or hits or does it bounce or not bounce. That part doesn't matter for just end behavior. So as x approaches negative infinity, the function, as we move to the left, the function is below it. It's at negative infinity. When x moves to the right, goes to positive x's, the graph is above it. The graph, the arrow, is above the x-axis, so it goes to positive. And that's all because you had an odd degree and a leading coefficient that was positive. In this case, we have an even degree with a negative leading coefficient. So what that tells me is the even degree says they go in the same direction. The negative tells me it has to be pointing down to the right. So it must be pointing down in both directions. So as x approaches negative infinity, the graph is below it. As x approaches positive infinity, the graph is also below it. For our next problem, I'll recycle another one of these. It's got some writing on the back side. But what we're doing, we're cutting out this corner. So we have this. So we can fold up our sides and make a box. We're going to fold up the edges. We're going to cut a square out of the corner. So if this is 20 all the way across it, the part that's right here is just going to be 20 minus 2x. And you can't see that at all. 20 minus 2x goes from edge to edge, and we fold those two pieces up. We're going to fold them up. So we have 20 minus 2x. And then this side is going to be 16 minus 2x. And when we do volume, because we're doing a box, the original cardboard is 16 by 20. And we're cutting out an X amount off of each corner. So the height is now going to be that X amount. When it gets cut, it stands straight up, that X amount. So volume equals length times width times height. Or in a different order, this would be your height and this could be length or width. Doesn't matter. So that would be our equation. No need to have to put it in standard form. That would be multiplying those all together. So if we put these into our graphing calculator and say x 20 minus 2x 16 minus 2x, put that into your graphing calculator, we can try to graph that out. we see that we get a little bit of movement here at the end. Let's look at the table to help us determine what we should be looking at. When x gets to 5, it's getting pretty high at 300. Oh, then it starts coming back down. It gets up to actually 420. Then it starts to come back down, and then it starts to go back up again, and it will go up forever. So negative 36 looks to be how small it gets, and then it goes down forever in that direction. So it looks like it goes as high as 420. So our window, we're going to go to a y value maximum at like 600. We'll make it bigger. We had to go down to 36, so let's like make it negative 50. And I'm going to make it go a little wider on the x's. I think that will fit us in well. See that? It curves through. What we're looking for is when we start cutting off the square at 1 inch, we have a small volume. 2 inches, we have a larger volume. At 3 inches, we're pretty much at our maximum volume. At 4, the volume starts to drop the larger the x gets. And then mathematically, you get so far out that it doesn't make a box anymore. And this is just mathematic to the equation, not to the picture. So we're going to find out our maximum value. So we have to be to the left bound of our maximum spot. Hit enter. Move to the right side, maximum. Hit enter. And then guess, you can get close to it if you wish, and hit enter. So that gives us two values. That gives us what the cuts should be. 2.9, and it says round to the nearest tenth. So the 4 rounds the 9 to just a 9. It doesn't change it. And that is inches. And the maximum volume is going to be the 400 number. 420.1 inches cubed, because it is volume, length times width times height, inches times inches times inches is inches cubed. So what will the final dimensions be? The final dimensions will be 2.9. Sorry, you couldn't see any of that writing. .9. 20 minus 2 times 2.9, because it's 2x from what we had earlier. And then 16 minus 2 times 2.9, because we found out that the x was a value of 9. So 20 minus 2 times 2.9. 16 minus 2 times 2.9. And by multiplying those three numbers together, 2.9 times 14.2 times 10.2, that is going to give us very close to what we were expecting here. All right. In the same format, we are going to type in our equation, x to the 5th power plus 2x squared minus 17x minus 4. So if I go to zoom number 6, that goes back to zoom standard. It still goes up a little high and goes down a little low. So you could look at the table and just see how high does it really go. It looks like it goes up to 14. It looks like it goes down to negative 18. So 25s seem to be a good number to watch it go up and down. Okay, so we're going to use our calculator to figure out the x-intercepts. So second trace, we're going to look for our zeros. we hit the second button and the trace button to go to calc. We're going to calculate the zeros. So we take our arrow or cursor to the left bound of our 0 and then to the right side of our 0, and then you can get as close as you want and hit enter. So we get an answer of negative 2.0 tenth hundredths thousandths it's suggesting us to round to. So 9/6. Now when we do x-intercepts, we like to put in x comma y. Now this is weird. This has an e in it. What that tells you is that this is exponent 10 to the negative 12th. So you're moving 12 point values to the left, 0.00000000001. So essentially that is 0. We have another 0 where the graph comes back down through it. So second trace, we try to figure out our 0. We have to be to the left bound, left of that 0, enter. To the right of the 0, enter. And if you want to get closer to it, you can try. And here we've got a small number, not quite 0, negative 0.229 tenth hundredths thousandths, comma 0. See, this time it actually gave us the 0 number. And then we have our last 0 to find on the far right. So we do left bound on the left of that, on the right, and hit enter to figure out, again, that's an abbreviation for 0 because it has the e in it, 1.971. 1.971 comma 0. Those would be your x-intercepts. We have 3 x-intercepts. The local maximum. Well, we go to second calc, go to maximum, and we're going to have to go to left bound. So we're to the left of it, then we're to the right of it, and enter. So these are just y values. 449. That's the only maximum value. We can't do a real max because the graph always goes up. But it does have a local max. It also has a local minimum. So we need to go to number 3, which is minimum. We need to be to the left of the minimum. Anywhere to the left. So I hit enter. Anywhere to the right. Hit enter. You can get closer if you want and hit enter. Your minimum is now y equals negative 19.074. For rounding to the thousandths, you've got to look at the fourth number to figure out the third number. And the y-intercept, that's where x is 0. A good way to do that is to just look at your table, and we can see that at 0, we're at negative 4. You could also look on your graph here, your equation, and if all the x's were zeros, we'd be left with negative 4. So it's an intercept, so we'll call that 0, comma, negative 4. The last problem. We'll go to Stat, hit your Stat button, and we go to Edit, and we need to type in our numbers for our big table, 9, 11, 13, 15, 17, 19, 21.5. Those are all our x values. 6.43, 7.61, 8.82, 9.86, 9, nope, 10.88, 12.36, and 15.24. The number of items you have in list 1 has to match the number of items you have in list 2. It wants us to find a model that goes through that, a cubic model. So we go to Stat again, go to your Stat button. We're going to arrow over to Calc. And if you go down to number 4 is linear regression, 5 is quadratic regression, 6 is cubic regression, and number 7 is quartic. But we're looking for cubic, so we need to do number 6. Your screen might look like this. Your screen might look a little bit different. You might just have to hit enter and you get your answers. I have to scroll down to get to calculate. You might just have to hit enter, and it shows you what your values are going to be. So I get a y value to be 0.00, we're supposed to round to the nearest thousandths, 5x cubed minus 0.194x squared. It tells me here what my equation is supposed to be like. Cubed, squared, x. So my c value is 3.132 because a 7 rounds it to a 2. That's just x. Minus 9.5. When we round the 9, then that rounds the 2. So that becomes a 3. So that would be our equation that would best go through all of those points. So if we would write that equation into our equation, if we type that equation into our calculator, alright, let's be sure we typed it in there correctly. We've got 0.005 x cubed minus 0.194x squared plus 3.132x minus that. All right. So we want to look when we get to 2400 RPMs. Well, these RPMs are in hundreds. So this is 2100. Then we would have 2200, 2300, and 2400. So we're looking for the 24 in our table to represent 2400 RPMs. So there it would be 23.014. And those would be knots. The table below gives the average speed in knots of the Trident motor yacht for several different speeds. All right. Good luck, everybody.